All right, so let's go about that. We're going to start the webinar. So what we're going to do is doing a sloping webinar. We're going to be talking about the sloping webinar. And what we're going to be talking about is how to put ground grid trench conduit on a slope. We have 2 customers asking about this, and we felt it would be worthwhile to put a sloping webinar together. So originally it was identified it was to be a grounding webinar, and then I was going to add sloping to it, but the sloping webinar itself grew larger and there was more to do with it. So the basic grounding webinar I did some time ago, and it's called the SDS Physical Webinar 2018. So if you want to see a basic grounding webinar, you can go on the SBS YouTube site and see this. There's also a lot of help files that way that you can be able to look at the help files. So things haven't really changed in the grounding world. So today we're talking about sloping webinar. We got about 30 people at least joined, and what we have is Dwayne. He wants his name here, so Dwayne is our National Sales Director. He wanted his name up here. It's Steve Coffin talking now. I've been with SBS for almost 3 years now. I'm a month away from 3 years. And here's our support email. If you have an issue with support, email us, and that goes to a whole team of people, and it gets traced. So I would use this if you have any questions with us. So today is going to be SDS Sloping Webinar. What I want to do is talk, before I get into that, is talk about the our website. In our website, we have a number of documents, and with our update on last Friday, we put out our 7.4.1 release. In that release, we have the we've changed dramatically the install method. So we've done a lot of changes with the install, the licensing, and with that we had documents change. So we have a new installation document. So if we highlight the installation document, you can follow this document, and anytime it changes, you can get an email. But we can go further than that. I was asking some questions about it. If we go into the general information, we can follow all the documents on here, and I can get an email if any of these documents change. So we can do that with every one of these major titles, that we can follow all the documents, and you'll get an email if all the documents change. Another document that has changed recently is the design checks. That has also changed. Physical health videos, you can follow those too if you hit follow. New articles and comments, and I can follow them all, and I will get an email. So I suggest to you guys to go ahead and do that. So 7.4.1 was released. The major change with that is the install and the licensing. And this is the release notes here. We have that. If you're following, you would have got an email. All right. So I just want to get that through. So back to the sloping webinar. So what we're talking about with sloping, if we look at, we often talk about sloping, a 2% slope for the entire substation, or maybe there's sections that are sloped at different angles, and that's what we want to look at, a method on how to get our trench, the ground grid, and the conduit on that sloping plane. We may also want to show how to get the islands or bays on a slope as well. So this is what we're going to be talking about today. What we want to do is be able to put this in accurately and repeatably. So we're going to be using, of course, the skeleton. The skeleton is key to get that accuracy and repeatability. So if we go back into the sloping, if we look at this, typically it's a 2% slope. It's not always, it changes to whatever you need for that site. And let's look at what happens when we have a 2% slope. And we're looking at some sloping tables here, and I went through it and to see, get an accurate numbers here. And when we look at a 2% slope, it's only a 1 degree angle. All right, so a 2% slope is 1 degree angle. I don't know if I can make that a little bit bigger. right? So we're talking about a 1 degree angle, right? So it's not very much of an angle. So on 100 feet, we only have to have a length of that angle of only a 1/4 inch longer on 100 feet. So on 600 feet, a 2% slope is only 1.33 inches on 600 feet. So that's not even a measurable thing on 600 feet. You can't get your tape measure 600 feet long and actually be accurate enough to measure a 1.33 inch distance. So as far as material amount on that slope, we can still quantify it, and we're going to show that today. We're going to quantify that 1.33, but I just want to stress, as a material issue, it's not a big deal. It's not even going to be measurable. It's out of tolerance. It's within tolerance, I should say. But the real issue here, maybe for those who want the slope in here, it's the drop on that. So a 2%, so on 600 feet, it's going to drop 138 inches. So that's significant. So if you think you have 600 feet of a 2% slope, you know, that's a lot, right? So that's what we're going to be looking at today. Just for those who want to know, is that this is the equations I use. So Inventor equation, we're going to get into Inventor and show how we can calculate that slope as a factor. This is a factor that we would use, and this is what I'm coming up with here, is this factor. All right, so it's not much material in that length, but it is a fair amount in that slope, and you can see it here, right? When we come up with the model, you can see how much. Here's on 40 feet, a 2% slope is a 9-inch drop. So you can see this island to this island, it's dropping. You can see the trench here sloping down, the ground grid sloping down, a little bit of conduit. So that's what we're going to be looking at today. So we're going to have three methods to look at that. So here's the 3 methods I put together, one for each. It's really the underground. The above ground stuff for sloping, it's not a big deal because your islands always sit level. It's just sitting on that slope. And we'll cover that at the very end on how to mate to a work plane that's sloping. But I think anyone with some Inventor knowledge would be able to do that pretty easily. But this method to get our Substation Design Suite to get on that slope is probably the challenge here. So if you look at the 3 steps that I put together, these are them. And remember, this is being recorded. It will be on YouTube, and you can pause and read these steps at that time. So what we want to do is create a AutoCAD ground grid sketch. So let's look at the ground grid first. Oops. Let's look at the ground grid first. We want to get a ground grid sketch, and we're going to probably get that sketch from the civil people as if it was a plan view. So it's a certain length. So let's look at what we'd want to do. So let's come into AutoCAD. And we may have a ground grid flat section like this. So if we're coming into here, and if you recall with creating a ground grid, we're going to create a sketch, and then on that sketch, we put our grid on. So the method to get that slope, and again, we have to identify that length. Remember, I showed you the length with the Excel. We got to count for this 1.33 inches along that slope, or whatever angle it's, whatever length it's, that added length it's going to be on that grid. So we have to bring that in. Once we bring that in, then we can create our ground grid. So just recall, for those who are rusty at it still, if I come into my ground grid, what we do with the ground grid, we create a sketch, and on that sketch, we will create all our cables and wires on that, right? So that we have this ground grid. So it's made off the sketch. Right now, as the software stands, we can only make that sketch on a flat plane. We cannot slope that plane and put the sketch on it. So we have to create it on a flat plane, and then we attach that ground grid to a slope plane in our skeleton. So let's look at the skeleton. I've created some planes on that. And you can see the planes on here. So we would create a flat grid, flat trench on our normal flat plane, and then we would attach to a slope plane accordingly. That slope plane, we're going to have to know where our 0 point is. And in this case, I created a 0 point here. I just made a point and made it visible. And that's where I rotated all my planes from, is from along an axis along there. And that's what made those angles. So what we're going to do, we're going to make the normal sketch on a flat plane, create our grid, and then slope it. But what we need for that sketch is that it has that factor in it to account for that, to be that little bit longer. So there's the method that I looked at in doing this, because so often we bring the information in from AutoCAD because it's given to us as a DWG. We bring it into AutoCAD. So let's go back to AutoCAD and look at the AutoCAD. Here is the unscaled. So this could be the plan view that we would get maybe from civil, or maybe you would lay out as a plan view when you're doing your work. So we have a plan view, and it's 2008 inches long, and that's what it's going to show in the plan view. But when we get on an angle, it's going to be slightly longer. So we need to get to that slightly longer length. So what we need to do in AutoCAD, it's nice that way. If I insert a block, if I make it a block and I insert a block, right, I can specify my scale individually, X and Y. So if I have my factor, let's go back to my factor. My factor on a 2% slope is 1.00018, right? That's my factor. So if I want to have that factor accumulated in my scale, I would put that number here, right? That's the type of factor. If I have a compound slope, and let's go back to the, in this case, I'm just going to show a simple slope, but if I have a compound slope where it's 2% one way and 1% the other way, I would need two factors. I would need the two factors of 1 and 2%. So let's go back into here. I have maybe a 1% on the Y. So I can take that value and stick that into my AutoCAD. Should be able to just paste that in there, right? Should have pasted in for this one too. But anyway, I can bring that in here in that slope, and then I have that compound factor, so that when I lay this on a flat plane, not sloped, and run my tool, I'll get accurate lengths for all my cabling. And then once I have that, then I'll be placing that assembly on a slope plane. So we can have that scale factor for the ground grid. You can bring that in here, and once you have that scaled, then you're going to have to explode it and then bring it into your Inventor sketch. So let's go back into Inventor, and it's just the normal creation of a ground grid in Inventor once you have that. So what we're doing, we're taking the plan view unscaled to what is required from plan. Then we have to scale it by the factors to get that degree of slope that we need. Then we have to explode it so that we can bring that sketch into our Inventor. So let's go into Inventor, and let's look at the scaled sketch. You can see the scaled sketch is placed in here. And it has that little bit of factor. It's only 0.4 of an inch on this size. This is over 2,000 inches. It's fairly long. And that's what the factor is going to be. And when you have that scale, it's going to scale the entire group. So it's not just scaling the length, scaling the location of all these cross members too. So it's going to be an accurate scale for that. And once we have that, we can build our normal ground grid. And you can see it's kind of hard to see here, maybe. You can see that we have our normal ground grid, and it's flat, right? So now when we bring it into our ground grid assembly, let's come into our grounding assembly. when we bring it in here, we're going to put it on a slope. And you can see it, oh, is that on the slope? Yeah, no, it isn't. So we have the ground grid assembly, then we place it in the next higher assembly, sorry guys, where we attach it to the skeleton that has the slope. So in here you can see in the skeleton I got a trench slope and a ground slope. So I placed it on the ground slope, and now I have a slope plane with my reference. Remember, I kept a reference on a point in my sketch, which is right up in here. I have that reference and I made all my planes sloping on that point. And then I can offset to what I need it to be. So now I have my ground grid, and it's hard to see. I'm sorry it's hard to see, but that's the way it is. You can see the ground grid is now sloped, and it's going to be accurate in length now. So if I take a plan view length of that, if you take a plan view length, you can see the plan view, it's sloped. This is the elevation view. You can see its slope, it's 2008. But if I look at the other angle, when it's not sloped, it's 208.41, so it's 0.41 inches longer. So in the plan view, we have it correct. It's going to show correct in our drawings, but the material that's going to be used is going to be 0.41 longer in that length. So that's basically the method for creating a sloped ground grid. But when we look at the trench method, you could do the trench method for your ground grid too. So let's look at the trench method. So if we come into our trench, so let's look at the trench. We're going to have the same type of slope, a 2% slope. And what we need to do, and as the practice users know, that we need a sketch to create a to create a trench. So here's a trench, and there's a sketch that we've made on here. It's strictly it's a line straight down, turns, and comes down straight again. So to create that factor on here, and again, we can only create the trench on a flat plane. We have to create it on a flat plane. Once it's on a flat plane, then we put it to the next higher assembly and attach it to the slope in the skeleton so that it's on that slope. And again, we keep that reference point. So what we need to do is use a factor and multiply all our dimensions by that factor to get that length. So if you come up to the functions, or the parameters, I call them functions because they have a big F in front. But if you look at the functions here, I got my angle. If I have a 1.1 degree angle, I calculate my factor. My X factor is going to be this equation here. And you saw that earlier in my Excel file. And that's the factor I'm going to use. So I'm going to multiply all my X directions by that factor. If I have a Y factor, I got to do the same. So we'll go back up here as well. If there's a Y factor, I would have to do the same. So the Y factor is only 1 because of the angle. This cosine, you know, it works out. Typical trig. So that's how we're going to do it. So if you have an angle on here, you would have to use a X factor, Y factor on, you wouldn't be able to draw an angle as in 45 degrees. You'd have to draw a line by that 40, let's see, if I had a line 45 degrees, something like that, I'd have to have a X factor this direction and a Y factor this direction, and then I can get that 45 degrees. So by placing this in with the factors, now I'm going to have an accurate for the length that is required, but that length is going to be nominal. It's going to be a very, like, again, I think we're getting too fine to worry about 1.33 inches on 600 feet. But if we can do it, why not do it? So once I have my trench on my flat plane, then again I attach it to my slope plane in my skeleton, and then it's on a slope. So now you can see the trench is on the slope. It's going to be an accurate length. It's going to calculate that 2% slope, and we're going to have it in there. Now, when we look at this trench, we look at the factors here. If we did not have our ground grid as an AutoCAD sketch and doing the scaling that way, we could also do the same type of technique for doing a sketch with the X and Y factor of doing a sketch strictly in Inventor and not going to AutoCAD at all. But so often we're using the AutoCAD world to do our ground grid. It just seems to be a pretty well industry-wide, but it's not a must. We can also, of course, do it in here as well. You create your X and Y factors, and away you go. And you can do those dimensions as well for that. So once you create this, you can constrain it to your work planes. So that's what I have my work planes in my skeleton. I got the base slope, trench slope, and the ground grid slope, and that's what I'm basing it on. So if we go further than that, so let's go to the next step. And again, this is recorded, so you can review it after the recording. And we're going to have a Q&A afterwards too. So if I look at the conduit now, so let's look at how the conduit is put together. So the conduit is a little bit different now. It's a little different animal. We're looking at, we want a vertical stub outs, and that's what we're looking at here. We got our vertical stub outs. We want to be able to bring that out to where we need it to be along that slope. So if we have our skeleton, let's look at our skeleton, and I have my slope plane, right? That slope plane is basically still referenced to me, top of concrete. We may want it to be stubbing out above, let's say, a trench line. You're going to come up with a number on where do you want it to be, and that's where I have this conduit stubbed out on, based on that line. So to bring this all in here, what we have is I've created a conduit base assembly. So if I look at this, it's hard to highlight. This is 2020 I'm using, and it's not highlighting. They've changed the way they highlight things. So if you look at my stub out, I've created a stub out. I've used Substation Design Suite. I've created a sketch, just like we do in the training. I have my height I want to stub out. I have my basics sketch here in my line that I'm going to follow. So I created a little stub out such as this. And now I have this as a part, and I can use this part anywhere I want. And I found in doing this, it might even be handy to do this as a practice, even if we're doing straight and not sloped methods, because it's nice to have a stub out that is consistent like this. So I've created this assembly, and I've placed this assembly in here, and you can see I have it constrained, right? I have it constrained to the skeleton. I'm locating it where I need it to be. And then I've placed my other stub out. Down here is my other stub out. So all these pieces are just added in afterwards. So if I want to create a piece of conduit, the conduit tool in Inventor in SDS will run a piece of conduit from one end to the other end and not worry about the slope. It will just place that conduit in. So we're able to do that as well. So that's not a big deal. We create our stub outs. We put the, attaching the stub outs to the skeleton slope plane so that it is sloped, and you can see it sloped here. And all I'm doing is attaching to the slope plane, right? I'm just going to stress that. You can see the slope plane, that my stub outs are attached there. And that's how we're attaching it. And then I just run my straight conduit between the elbows at the bottom of my stub outs. So here I got 3 different methods of putting this together. So let's look at my general arrangement. So we have it all on the slope, and you can see it here on the slope. I put a couple islands on here. The ground leads work fine to a slope. I've attached it to the slope wire here, and I ran the lead out, so we're able to easily put that in. My islands are attached. Let's look at the islands. So that's above grade assembly. Let's look at the above grade assembly. You can see the different levels here. You can see my slope. I'm basing it on my slope here. And I just constrain my islands to my skeleton. So they're constrained here, and I think here, one of these. So they're constrained to those islands. And then my last constraint's a mate to the origin point of the island. So I'm mating down here, the origin point of the island to that slope. And if I need to, if it's a requirement, something special is happening, I can always change this mate to have an offset of, let's say, 5 inches, or whatever I want it to be. If I want it to be, let's say 20, just to show that we can change it, right? So I can also adjust my angle, adjust my height accordingly. So when we look at our drawing world, so here's our assembly. We have this slope. I have my site skeleton, of course, for reference. I have my above grade assembly. I got my grounding assembly, and I got a ground lead in there. And come into the drawing world, and you can see that I have it sloped 9 inches drop between the two. You can see it clearly here. You can see it up here. I'm going to turn on my work plane so we can see everything here. Is this the right one? Yeah. Let's include those. So we have that shown, and you can see that it's 2,208, which is the plan view length. And if I took a length down here, as I showed in this drawing, in my grounding assembly drawing, you can see that 2008 in the plan view is 2,208.41. And that's a method of creating our sloped items in there. Now I'm going to open it up for a Q&A. So I think if we do more webinars, we'll all get more practiced at this. So if you have a question, ask, go ahead.
Hey, Steve, this is Jim from Burns & McDonnell. Can you hear me?
Yes, I can. Thank you.
Okay, I just had a small question for you. So you're talking about the X factors, and the calculations involved in getting the slope gradients. Is that something built inside of SDS Suite, or is it Inventor-based only? Or
it's configured by the user. So I'm putting that X factor right into the Inventor parameters. So if we look into, if we look at here, I've calculated into the parameters that X factor. Where is that one? So it's a factor built into here. It is. And I show it here. Right? So that's the factor I'm bringing it in. And it's just normal math. So I'm taking the slope. A 2% slope works out to be 1.1 degrees. So that's what the Excel file. If you guys want the Excel file, I can give you the Excel file too. But in here, you can see a 2% slope works out to 1.1 degrees. And then that's what I use for the angle to calculate the factor. So that factor is basically this equation here in Excel, or this equation in Inventor. And that's what we're seeing here in Inventor.
Yeah, I got it. Thank you.
Okay.
Would you email the Excel sheet
Sure.
along with the today's agenda, please?
Yeah, I can do that. We can do that. I'll email
Okay.
the Excel sheet, and someone's asking to get the PDF of my notes here. So we
Yeah,
can
the
do
PDF
that
of
as
your
well.
notes would help as well.
So that's basically what I followed through. Is the 2% or 0.2% slope? It is a 2% slope. So when you look at the chart from the sloping people, a 2% slope is 1.1 degrees. A 0.2% slope would be very, very small. This is how the ratio. So 2% is this ratio here, like a 33% is 3:1. Any other questions?
So this may be a little off topic, but I was wondering if we can use the same calculations for transmission poles as well. You know, anything outside the substation periphery, excuse me.
Since it's math, and anywhere where you can use the math, you can use the calculation. So it would be, you could transfer it easily. So if anyone has questions on the 7.4.1 release, I think that would be licensing explanation. So the licensing changed, and it's kind of nice that way. Let's look at, I have a document on that. So I shared it with the consortium people. So those who are aware of the old licensing knew that we were licensing to aflicense.com. And aflicense.com was it was not a HTTPS. S means secure location. It was a whitelist location. So we always had a hiccup of people making sure that their IT department had this white listed so that they could look at it. So we've changed the licensing location to this site now. It's a secure site, and it's going to work a lot smoother, and your IT does not have to worry about trying to whitelist something. What we've also did is change it so that people are alerted when their licensing is about to expire. Let them know. It's another headache we have been having. So we're always trying to improve, and I think we certainly improved it here. And the number of days before expiration is going to be told to you. It's going to be emailed and alerted to you. You're going to know. Customer points of contact will be also emailed out. So like if you put yourself on a list of point of contact, we're going to have that ability to say, hey, it doesn't just go to the IT department or some marketing guy or some sales guy, that it might actually go to some of the users that want to see this information. So it can go out to a list of users. What we also get is a number of users will be trying to get on their licensing, and because of the restrictions, you might have only bought 5 licenses and you got the 6th person trying to get on. It's going to alert you that, hey, you got too many licenses in use. The other thing, this is my favorite, is the last one here I have listed is the one installer. Instead of looking for a 2020 installer and a 2019 installer, what we can do now is that you have one installer for whatever Inventor you have installed. So if you're using 2019, you download the installer and away you go. You don't have to look for a 2019 installer. So all this information, again, we've changed the install document. I'm going to stress that. This is great reading. It will put you to sleep every night. but this install document has been updated regarding what these changes are. Okay. So I see a couple of other items here. Will there be only need to be one install if you're running multiple versions of Inventor? Correct. You'll love that, Jeremy. That's a great one. So again, if you have 2018, 2019, and 2020 installed on your machine, you can install the one installer and it will work for all three. The caveat there, of course, is that if you have the old if you have the old software installed, you're going to have to follow the uninstalled tools, and specifically this line here. So Jeremy, if you're going to be doing this, make sure you follow this line as well. So if you had the previous to the 7.4.1 release, follow those steps. So I'm really happy about that. That really saved me some headaches alone. So thank you. I got a big thank you from some people. I think I'm the same person. Keep saying thank you. What's going on, Jeremy? All right. So I think this is really good news for us. My understanding, we're going to do more incremental releases with the SDS, and with this new installer, it's going to be so much easier to update those incremental releases. So again, I would come up here into general information and I would click this button to follow it so that you get an email if documents change. I'm going to be trying to update more documents as we go along. There's a number of things I'd like to change and update. We've talked internally, and I think it's a real good thing to do. Do we have any further questions? Have there been changes on how the database is handled in a network environment? So right now we have one database and we have to handle it with some methods of doing that. So it is an enhancement request to get our database be able to use easily in a network environment. We have a method of doing that right now, but we want to go further with that, so we'd like to split up the database that way. It is an enhancement, but there's no timeline. It's a major amount of work to separate that out. If you are in a network environment and you want to get your database shared and updated across a group through the network, we have our configuration in here. This file here, I would suggest you talk to SDS support, email them that you want to get this working across a network environment for the database, and we can work with this configuration file to be able to do that. Will the SDS tools be updated automatically in the future? There is nothing for us on that. I would not, as a user, want that to happen because I'd like to be aware if something's changed and know what those updates are. So I'd be hesitant to do that. Not even Inventor will update automatically. So my next webinar, I hope to do it early September, maybe the second week of September, maybe. And that would be on design checks. I want to look at different ways of doing design checks. So I've had some questions on that. I know Jeremy wanted me to talk about design checks. I've had other questions on it. And I've noticed a couple things that people are asking to do with design checks, and I have some ideas to show different ways that others are using it, so I think it would be worthwhile. So I hope to do that early September. Okay, I will end the webinar. If there's any further questions, please speak out. You also can go to the SDS website or the SDS support I'm sorry, the SDS email, and email us if you have any support issues, questions as well. So thank you all for joining. It's great to have you all out here. Thank you.
Thank you.